Okay, I want to send the solutions to the review packet that most of you received today. Some of you actually, if you didn't have math class today, you'll receive this tomorrow. But I do want to go through this. Now, many problems are similar, so I might go through some a little quickly if we've done the same types of problems. So let's look at number one here. Okay, this asks for the cube root of negative a to the 15th b to the 6th. So there's a couple of ways to do this. What I suggest we do is first, let's see what it looks like here. So I broke down negative 8 to negative 2 times negative 2 times negative 2. And we know that when there's a cube here, I need 3 of the same thing underneath the square root sign. So these 3 come together, and 2 of them cancel out, 1 goes in front. So that's going to leave us with negative, well, that's what happens right here. And now I have a to the 15th to deal with. And a to the 15th, if I think about this, 15 divided by 3 is 5, and 6 divided by 3 is 2. Now, I could have written out 15 A's and done all that. It takes a long time to do. But this way, it's a little quicker. This becomes A to the 5th and B to the 2nd, and then negative 2. So the correct answer should be B right here. Okay. There is another way you could have done that. Another way, more, I don't know, advanced, just a little different, would have been to say this is negative 8 a to the 15th, b to the 6th, the whole thing to the 1/3 power. Because this symbol here with the 3 means to the 1/3 power. That becomes negative 8 to the 1/3, which is negative 2. A to the 15th to the 1/3, which means we multiply the exponents. 15 times 1/3 is 5. And then b to the 6th to the 1/3, multiplying 6 times 1/3 is 2. So that works as well. Either way would be good. Problem two, there's a couple of ways to do this. This is the first way we kind of learned to do this, was to, we can't have a square root on the bottom of a fraction, so we multiply square root of 3 over square root of 3, and we get this mess right here. So now I have the square root of 864. So 864 breaks down to be a big mess, 2 times 2 times 2 times 2 times 2 times 3, all that kind of stuff. So it looks like this then. This is kind of what I have now. And then I take out pairs, so I can go through and circle pairs of things. So I could have a pair here, another one here, another one here, and that's going to come out. And then, of course, one here to make the whole thing comes out. And then it looks like this. 2 times 2 is 4 times 3 is 12. So I have 12 square root of 6, because 2 times 3 gives 6, over 3. 12 over 3 reduces to here. And that's fine, and we can do it that way. There is an easier way in which to do this. When you have square root over square root like we have here, we can simply make it one square root to be square root of 96, because we make it put the square roots together to be the square root of 288 over 3. And 288 over 3 is 96. But then I still have to break down 96 the same way I've done before, and that takes a little bit of time. Oh, come on, what's going on here? So I break that down, and this becomes similar. It becomes 2 times 2, that's 4, and then left is square root of 6. So that gives us 4 square root of 6 as our answer. It works the same way. Okay, next problem. And this one we just want to break down. Right now we can't add them together because one's 54 and one's 20. Square root of 54 and square root of 24, we can't add them together unless the under the square roots are the same thing. At this point we say we can't do it, but then let's look at what we have here. Square root of 54 becomes, well, square root of 54 becomes, what am I doing here? 3 square root of 6, because 2 times 3 times 3, this becomes 3 square root of 6, and square root of 24 becomes 2 square root of 6. 2 times 2. Our simple rules here, these guys come out to be a 3. These guys come out to be a 2. And so now the answer will just be 3 square root of 6 plus 2 square root of 6, which is 5 square root of 6. Okay, let's move on to the next problem. This one, a couple of ways we could do it. We could break down 8 and break down 10. What a lot of people tend to do is just make this square root of 80, because 8 times 10 is 80. And that can break down to 8 times 10, of course, because that's where we got it. And then that becomes 2 times 2 times 2 times 2 times 5. And then we look at the common things here, and we say there's this, there's 2 times 2. So 1 cancels out on each one, and 1 comes out. So I have 4 out front and square root of 5 underneath. And that's it. Okay, next problem. Similar to the last one with a few extra steps, of course. Our first thing might be to distribute. So 2 times 4 square root of 6 is going to be 8. 2 times 4 is 8. 6 times 10 is 60. And then I multiply 2 square root of 6 times 3 square root of 15. We just distribute. And then we get 6 times the square root of 90. So now I have to break down each of these. So 8 square root of 60 becomes 8, and then 60 is 2 times 2 times 3 times 5. These guys are going to come out. So 8 times 2 is 16, and then square root of 15. So that part's done. And then when I look at the square root of 6 times the square root of 90, now that becomes square root of 90 is 2335. So what comes out of there is the 3. So 6 times 3 is 18, so it's 18 square root of 10. So we have, basically, there's our answer. So it's going to be 16 square root of 5 minus 18 square root of 10. So A is the answer there. And now number 6. We just have to do FOIL with this one because we have two binomials multiplied together. With that, we multiply. And so we basically are going to look like this. 3 times 3, that's 9. 3 times negative 4 becomes negative 12 square root of 2. And now we do with the green, 4 square root of 2 times 3 is plus 12 square root of 2. And these are going to cancel. So, and then 16 times 2, because 4 times 4 is 16, and square root of 2 times square root of 2 is 2. So that becomes negative 9. These two are going to cancel out. Negative square root of 2, 12 over 2 plus 12 over 2 cancel, and I have negative 23. So that's the answer there. This one we have a denominator with a square root in it, which is not what we want, because rationalize the denominator means there's no square roots in the denominator. And when we have a binomial down here, we have to multiply the top and the bottom by the conjugate of that. And the conjugate of that is going to be 3 plus the square root of 2. It's basically the same thing with the middle sign change. First sign stays the same. So now what I like to do with when we have things like this is just take it one at a time. Let's do the numerator first. So that's going to be 3 times 1 is 3. 1 times square root of 2 is square root of 2, and then I have square root of 2 times 3, which is 3 square root of 2, and square root of 2 times square root of 2 is 2. So that becomes 3 plus 2 is 5, and then 1 square root of 2 plus 3 square root of 2 is 4 square root of 2. So that's my numerator. The denominator now is denominator. I'm going to do similar to what I did with the other one. I have to FOIL these guys. So basically, 3 times 3, that's 9. 3 times square root of 2 is 3 square root of 2. 3 times negative square root of 2 is negative. These will always cancel if we use conjugates. And square root of 2 times square root of 2 is 2. So 9 minus 2 is 7 is my denominator. So my numerator over my denominator. And then that will just give us the answer of that. So 5 plus 4 square root of 2 over 7, which is this one right here. Okay, next problem. Okay, I'll skip that. Hold on. This just asks us how we're going to write the square root of negative 8. Now, anytime we have a negative under a square root, we aren't allowed that. That's not possible to have a square root of a negative number if we're dealing with real numbers. When we talk about imaginary numbers, now we can do that. So the way that we work that is imaginary number I, which is right here, And basically what it does is a negative under a square root comes out as an I, so it looks like that. So the square root of negative 8 becomes I times the square root of 8. So now I have to break down the square root of 8, and 8 is 2 times 2 times 2. So these guys are going to come out. One cancels, one comes out, and then I'm left with this is my answer. So there we go. Okay, number 9. Number 9, I'm going to go through this one. I'm going to say it's similar to the last one in that we have to 3 times negative comes out as an I, and now I've got to break down square root of 27. Square root of 27 is 3 root 3, so that becomes 3I, which is basically from here, and then 3 square root of, so 3I is there, and then we'll do different colors. Square root of 27 is here, so I multiply 3 times 3, and I get 9, 9I square root of 3. All right, next problem. Now people still are having trouble with this, and we have to figure some things out. This has to be basically memorized, or at least these two, and you can determine these two based on the I squared is a negative 1. And what we do is we take the number 61 and break it down, basically divide it by 4. Some people actually go through the old-fashioned method of 61 divided by 4, because we want to figure out what the remainder is. And I don't really care what's up here, whether this is 15 or 20, or it doesn't matter what that is. The key thing is what's the remainder going to be, and this is the key thing down here, the remainder. So basically what that means is this is just becomes, oh, I didn't write this right, that's not right, 60th. I'm thinking of 60. What it really is, oh, I guess it is out of the 60th. What am I thinking? That is correct. So I to the 60th times I to the, so I to the 60th basically would be, the method of this is I to the 60th, since 4 goes into 60 evenly, there's one more left over, so basically it's I to the first. I hope I didn't confuse you too much with that. I'll go over that more in class on Thursday. This uses the same procedure, I to the 8th. We're going to have to use this thing over here again. Sorry about that. We're going to have to use this again. But I to the 8th becomes, since 4 goes into 8 evenly, that's just going to be 1. Whether I write it like this, it doesn't really matter how you write it. That's what it's going to be. And then I to the 3rd is negative I. So that just becomes 1 plus negative I, or 1 minus I. Hopefully I'll get through this fairly quickly. Let's see this. This is kind of the same thing. What we're going to do is remember this over here, and then we have, so all these I to the first, I to the second, I to the third, I to the fourth, that's all what we have right here. So we're going to rewrite this as 2 times 1, because I to the fourth is 1, plus 5 times negative I, plus 2 times negative 1, plus 4I plus 1. And then we just simplify that to be 2 times 1 is 2, 5 times negative I is negative 5I, minus 2, plus 4I plus 1, and then we combine like terms. So first I'm going to combine the non-I, the terms without the I's. So it's going to be this one, and this one, and this one. 2 minus 2 is 0, plus 1 is 1. And then I'm going to go ahead and combine these guys over here. Negative 5I plus 4I is negative 1I. So that would be my answer, 1 minus I. All right, for this one now, it's basically using distributive property. So I'm going to say 2I times 5, which is 10I, and then 2I times 3I, which is plus 6I squared. And at this point, we're not quite done because we have I squared, but we know that I squared is negative 1, so that becomes 10 plus 6 times negative 1. But 6 times negative 1 is just negative 6, so it's 10 minus 6. And we write it with the real number first, real part first, and then the imaginary, so that's the answer that we're looking for. Negative 6 plus 10IC. Number 14, oh, I forgot to cover these up. Okay, well, that's all right, we'll look at it now. This is just a FOIL problem. 5 times 3, that's 15. 5 times 4i is plus 20i. Negative 2i times 3 is negative 6i, and then we get negative 8i squared. And that, now we go to the next step, and that's 15. We combine these two together to make plus 14i, and then I squared is negative 1. So 8 times negative 1 is, negative 8 times negative 1 is positive 8. So now we add 15 plus 8, and we get 23 plus 14i. Okay. This is basically the same type of problem. The only difference is, well, they don't write it in that form, but product means multiply, so that means it's going to look like this. We're going to FOIL. So 3 times 2 is 6, 3 times I is 3i, then 6 times 2 is 12i, and 6 times I is 6i squared. So we're going to go through the same steps as the last one. So that's 6. We add together these two terms. 3 plus 12 is 15. And then I have 6 times negative 1 here. So 6 times negative 1 is negative 6, but 6 minus 6 cancel, so I'm just left with 15i as my final answer. All right, number 16, the conjugate. This should be easy for everyone to do. Basically, when we write the conjugate, it's going to be a binomial, two terms, and the conjugate just changes the second part of this term. The one before the I will be changed. So negative 3 stays the same. Positive 2i changes to negative 2i. So for that one, we're going to have this answer right here. Negative 3 plus 2i. All right, next problem. We use the conjugate to solve this, to simplify this one. When they have 2 minus 3i, we can't have a square root in the bottom of a fraction. So our steps would be to write it like this. So we just multiply top and bottom by the conjugate of this, which is 2 plus I. The top we distribute to 1, which just becomes 2 plus I on top. In the bottom we can do FOIL. 2 times 2 is 4, excuse me, and then plus 2i and minus 2i, and then minus I squared. So that becomes 2 plus I. The 4 on the bottom, these guys are going to cancel. And I'm left with 4 minus I squared, which is 4 minus negative 1, or 4 plus 1, which is 5. So 2 plus I over 5 would be the answer to that problem. All right, we're getting through this. Number 18. Again, I forgot to ask it. I didn't cover it up, but we'll just look at it. We're going to distribute here. So in this case, what we would think of is, if I do it like this, 5 times 3, that's 15. 5 times I is 5i, so minus 5i. And then the bottom, we're going to do FOIL again, and I get 3 times 3 is 9, minus 3i plus 3i, minus I squared. Now, minus I squared means plus 1, because minus negative 1 is plus 1. So the top becomes 15 minus 5i, and the bottom becomes 10. Now, that's not one of our solutions here, because we have to reduce. Now, when we reduce binomials over monomials, we have to divide the same thing to all three terms here. So we divide each of these by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. 10 divided by 5 is 2, and that's what we get for that one. All right, this is a problem we had on our exam, one of our quizzes, which is the one that didn't have the answer. I'm sorry for putting that back on. This is neither of these solutions works, or none of these solutions works. So let's just look at what it looks like here. We'll go through the steps anyway. We should be able to figure it out. So we start with this here, and I got to figure out, let's just go through the numerator first. So for the numerator, I'm going to say negative, it's basically multiplying these two together. So 2 times 4, so it looks like 2 times 4 is 8, minus 4i, minus 12i, plus 6i squared. That becomes 8 minus 16i. Negative 4i minus 12i is minus 16i. And then minus 6 here, because I squared is negative 1. So 8 minus 6 is 2, and then minus 16. So that's the numerator. And the denominator now can be written like this here. Denominator is 4 times 4, which is 16. Let me get this out of the way. So 16, 4 times 4 is 16, minus 8i plus 8i here, minus 4i squared, but I squared is negative 1, so it becomes plus 4. So the bottom becomes 20. That's what we have here. And then reduce it has to reduce to all of them, so the answer would be 1 minus 8i over 10. Unfortunately, that's not one of our solutions. So for this problem, actually this won't be on your test, but this is an invalid problem because none of the solutions works. All right. This one here is just a straight FOIL, but we have x in here, so it mixes it up a little bit, but it shouldn't be a problem. 3x times 3x is 9x squared. 3x times negative 5 is negative 15i. And I did write this wrong. Okay, let's see what I can do here. Make this right here. This should be 15. I want to go here. This should be 15 here, because 5 times 3 is 15. Okay, so this is what it looks like, and then these guys will cancel, and I have 9x squared minus a negative 20, minus 25 times negative 1 is plus 25. So that's the answer there. Same thing with this problem. We're going to multiply. It's basically the same problem, just practice, more practice. 7 times 7 is 49x squared here, 7x times 7x. Then we get minus 28i, and then this is ix, excuse me. Oh, I'm losing it today. Let's get this right here. That's 28xi, and then this is 28xi as well. They do cancel out anyway, but I should have had that from the start. These are going to cancel anyway. So, and the last one is 16i squared. Minus 16i squared is plus 16, so that's what we get for that one. Sorry about that screw up there. Number 22 is the same kind of thing, only with this time it's not, things won't cancel. 3 times 3 is 9 plus 12i. And then we say minus 12i for those, negative 4i times 3. Then 4i times 4i is plus 16i squared. These two will not cancel anymore because they're not opposites like they were in the past. So 12i plus 12i is 24i. 16i squared is minus 16, so 9 minus 16 is negative 7 plus 24i. All right. Okay, there's a similar thing here with x's. Now these, you can kind of see, since these are conjugates, the middle term is going to cancel out. We should be able to recognize that enough times here. So now what we have is x times x is x squared. X times negative 7i is minus 7xi. And then 7i times x is plus 7xi. And then 7i times 7i is 49i squared. So we have that, and now these guys in the middle will cancel. 7xi minus 7xi cancel, so x squared minus 49i squared. But I squared is negative 1, so it's plus 49, and that's what we get for that one. Okay, when we get to absolute value symbols, equations, what we need to do is write two equations to get rid of our absolute value sign. The absolute value sign has been isolated on one side of the equation, so that means it's going to be two equations. In the thinking process, and a lot of people kind of miss this whole concept, but this whole thing here is going to be it's going to end up equal in one number. Okay, that's going to be just one number. If that number happens to be 12, oops, let me erase that. If this number is 12, then it looks like this. But if this number that I circled is negative 12, it's going to look like this. Right there. So we have two possibilities. So now I've solved this one by subtracting 4, and I get x 1 half x, or n equals 8. 12 minus 4 is 8. Now to get rid of the 1 half, we multiply both sides by 2, and then we end up with n equals 16. Over here, we go through the same process. We're going to subtract 4 from both sides, and that's going to give us negative 12 minus 4 is negative 16. These guys are going to cancel. And now to multiply by 2, I get negative 32. So I have 16 and negative 32 as solutions. Now with absolute values, we really need to go and check them all the time. I can leave that a little, I'll do it quickly, but you should be able to make sure you can do that. 1 half of 16 is 8, so 8 plus 4 is 12. Absolute value of 12 is 12, so this one works. And we put negative 32. Half of negative 32 is negative 16. Negative 16 plus 4 is negative 12, but the absolute value becomes positive. So we do have two answers B. Okay, same problem, similar problem here. It's a little more confusing with the 2x, 2/3 x, or whatever, 2x over 3. But again, this entire thing inside here could either be 3 or it could be negative 3. And then we solve each one. So we add 1 to both, or subtract 1 from both sides, and I get 2/3 x equals 2. Now what I like to do is then, you can do it all at once, but generally we can multiply both sides by 3. So if I just say times 3, these are going to cancel, and I have 2x equals 6. Now I divide by 2, and I get x equals 3. And on this side over here, I do the same thing. I'm going to subtract 1 from both sides, and I have 2/3 x equals 4 multiplied by 3. So if I multiplied both sides by 3, I get this. 2x, the 3's are going to cancel, and my 2x equals negative 12. X equals negative 6. And when I put those numbers in, I'm going to leave that to you for you to do, but that does work. If I put 3 in here, 6 over 3 is 2. 2 plus 1 is 3. Absolute value is 3. That's good. Negative 6 times 2 is negative 12 over 3 is negative 4. Negative 4 plus 3 is plus 1 is negative 3. Absolute value is also 3. So that does work. Okay, sometimes though we get problems. Well, we'll get to that one in a minute. Okay, these are inequalities, which make it a little bit different. There are some similarities. We do have to still write two equations, or technically inequalities. The first one we write as if basically saying if this whole thing is positive in here, then the absolute value signs don't mean anything, and I have this. And to solve this one, I'm going to add 5 to both sides, and then I'm going to get this, divide by 2, and I get x is less than 3. In this one over here, I'm going to say 2x minus 5. I do two things. I switch the direction of the arrow, and I change this sign to negative, the opposite. And then I have a problem like this. Add 5 to both sides. So I get 2x is greater than or equal to 4, which means x is greater than or equal to 2. And that's that. And then I look for that. Which one has that? Well, it has to be greater than 2. So it's from 2 over. So that's only this one, and then less than 3. So it's basically just this one right here, A. Now I'm going to show you a different way. Because it's multiple choice, and this is one that's frustrating for me as a teacher, in that a lot of us aren't thinking very well. My suggestion is, let's look at this and put some numbers in and see if it works. So what if I put 0 in for x? If 0 were x, this would be, that would be absolute value of 2 times 0 minus 5 is less than or equal to 1. 2 times 0 is 0. 0 minus 5 is less than or equal to 1. 0 minus 5 is negative 5. So that the absolute value of negative 5 is less than or equal to 1. So 5 is less than or equal to 1 is not a true statement. Since this is not true, that means it can't be part of my solution. Well, if I look at the 4 solutions I have, this one here has that in it, has 0. This one has 0 as part of the solution. This has 0 as part of the solution. So these are all no good. So this is the only one that could possibly work there. So sometimes, even if you don't know how to do this part of it to make it 2 equations, you can at least plug numbers in and see what works. 27 is a little tricky because there's a lot of words in it. It's really not that hard when you think about it. We're basically saying what we want to, if the resistance has to be between 12 and 15, this is the resistance right here. That's the resistance. That has to be between 12 and 15. So let's say the lowest it could possibly be is 12. So that's going to give me an equation, or an inequality that looks like this, equals 12. So 12 equals V, because we still don't know what the voltage would be, but the current is 5, because it tells us 5 amperes. So the current is 5. So this is what we get. So I multiply both sides by 5, and I get, what do I do? Oh, it's over here. V equals 60. Now, the biggest it could ever be is 50, the resistance could be as 15. So that would look like this then. And multiply by 5, and I get 75. So basically, it has to be between 60 and 75. So that's going to be this one right here. Okay, a couple more problems to finish up. This one's kind of a weird one because it has all this sum of this and whatever. Okay, when I looked at this, I said, I'm trying to figure this thing out. The sum of 3 times a number and 8. So the sum means add 3 times a number. 3 times the number plus 8. That's the sum of 3 times the number and 8. Is not less than 2. Well, that means it has to be greater than or equal to 2. So I write it like this. And then I solve this by adding 8 to both sides, and I get 3x is greater than 6, or negative 6, excuse me, greater than or equal to negative 6 divided by 2. X is greater than or equal to negative 2. But is less than 7, so that means that 3x minus 8 is less than 17. And I solve that one by subtracting 8 from both sides, and I get 3x is less than 9, x is less than 3. So basically what it comes down to is these two things right here, this one and this one. So x is bigger than negative 2, or equal to, and less than 3. So that's going to be in between negative 2 and 3, so that's this one here. Okay. And then 2 more problems to do for this worksheet. This one, we want to go through the steps of solving this. So we'll start with the problem just as it is. And what I like to do is figure out, we're going to add a number here to make it a perfect square. So to do that, I left spaces, and then I fill the spaces in with half of this number, which is half of negative 2 is negative 1. Negative 1 squared is 1, so I get 1 and 1. And now this will factor to be x plus 1, x minus 1 squared. This number here is always going to be half of this if we selected the correct number, which we did. And then the right side is just negative 4. And then the next step would be to take the square root of both sides, which looks like this. Remember, when we take the square root, we have a plus or minus. Now, square root of negative 4 there's no square root of negative 4. We take the I out to be, that becomes then I times the square root of 4, but the square root of 4 is 2, so that just becomes 2i. So x equals negative 1 plus or minus 2i. We add 1 to both sides, and x equals 1 plus or minus 2i. That's the answer to that one right here. And the last problem for this worksheet, same type of problem. It's a little different though, because the x is on this side over here and the 10's here, and we don't want we're not going to be able to complete the square like that. So what we have to do is get this problem to look like the one before. So what I'm going to do first is I'm going to add 6 to both sides, and that's going to leave me with this. And now this doesn't factor, so I'm going to have to go to the next step to get rid of the 10 to complete the square. So I subtract 10 from both sides, and I get this. Notice I left spaces because I want to complete the square. So the number that goes here is half of 6, which is 3 squared. So 3 squared is 9, so it looks like this. Now notice I add 9 here. I got to also add 9 over here. So now at that point, I look at this left side. I selected this number specifically, so this would be a perfect square. Half of 6 is 3, so it looks like that. X plus 3 squared, and negative 10 plus 9 is negative 1. Now I take the square root of both sides, plus or minus, and the square root of a square just becomes x plus 3. and then the square root of negative 1 is I. So plus or minus I subtract 3 from both sides, and that's what I get. Okay. Hope this helped a little bit. I know it's kind of long problem, but it is a lot of problems to practice, and it gets you better and get ready for the intermissal.